Welcome to the talk. Well, today's talk, well, will be about load tests, but it will be directed to developers. So there will be, well, code on slides, code in an IDE, and everything. Well, if everything goes right, there will also be a demo to look at. So we will look why to do load tests in the first place. Then we go through all the steps to set up a load test environment with the demo, and then I also bring some lessons learned from a previous project and how this actually then turned out for us. So, and you are, well, free to ask questions during the talk. Somebody will come with a microphone and we will, well, get the answers during the talk. Well, then why to use load tests in the first place? The naive approach is, well, maybe I don't need them. And then, well, I do some development. He or she will develop software. It's perfectly working on the one single machine of the developer. And then you give it to a colleague, and he or she tests it functional-wise. Everything is good. You go to production, and your product is successful. Lots of people try to use it. But then the machine catches fire, and yeah. And, well, you don't actually, well, you know there's lots of people out there that are trying to use your application, but what is actually happening to your application? Is something slow? Is there maybe a queue or a connection pool to your database that exhausted? You basically don't have any observability. And, well, what is helping with observability? That's, well, some monitoring and then also do some load testing in the first place. So we start again, new project. We do some development, but then we do, well, the functional testing, but also load testing, and we use tools for that. The tools that I will show today will be Gatling, but you can also use something like JMeter that will react quite similar. And then still, this load testing tool will set your server on fire. Besides that, all the slides will be later on Twitter. You can download them, that's fine. So these load testing tools, they will set your server on fire, but that's a test environment. That's okay. So, but then what? You still don't know what's actually happening to your application, what's going wrong here. And, well, let's add some monitoring. And the tool that I will use here today is going to be Prometheus. And we add a monitoring tool to that, and we monitor as many metrics that we need to really understand how our system's operating, what are the critical factors. Do we need to monitor response times? Do we need to monitor connection pools to the database? And as we add more metrics and as our understanding grows, well, the load tests no longer put our server on fire. And, well, then we ship to production with confidence. And the thing is, all the metrics that we put into our application and the environment, all the monitoring, we can use that same monitoring also in a production environment. At least for a start. There will be some surprises maybe in the production environment as well. But then, is there like a first-class citizen metrics in your application and the proper alerts and probably dashboards that go along with it? So that's the idea that I'm presenting today. So then, how to set up a test environment to do something like this? Well, I'll show you how we did this in my projects. So we set up some monitoring. Monitoring is going to be Prometheus today. It can collect host metrics. It can collect application metrics. And all these metrics are then stored in, well, its own database that comes with Prometheus. All these metrics that are stored in Prometheus can then be queried and put into dashboards, usually then Grafana. And, well, you can also do alerts. Alerts are then usually for production, but all the metrics and all the dashboards, you also need that to monitor your load tests in the test environment, right? All right, so yeah, that's the big picture again. So let's go into Prometheus. What you can do with Prometheus, it's a time series database. Basically, it ingests a lot of data, puts it into its own database. You can instrument your application and infrastructure. You can collect all this data, you can store it, you can query this information, use it for alerts, dashboard, and also some trend calculation. It has, well, a Prometheus manifesto, at least that's what I call it. So there are some things Prometheus values more or has been built, designed to do, compared to other things. So it's there for operational systems monitoring. So it tells you very exactly what your system is doing at a specific point in time and maybe a little bit of history. And that's something we want to have for production and for our load testing environment. We want to have a simple to set up structure for a server, and that is capable of storing, well, at least some weeks of storage. In a load test environment, we want to compare the last or the previous 2 or 3 load tests with the current load test. And in production, we want to compare the previous release with the current release. So usually, some weeks of storage are enough for us. All the configurations will be stored in a configuration file. So that makes it easy to stage it from a development machine locally to different testing environments and also to production environment. So the term GitOps that we heard today in the keynote is possible with Prometheus because it's all stored in configuration files. It will be pulling the data from different nodes and infrastructure elements, what we see in a minute. And, well, it has its own database, a NoSQL database that allows us to correlate all the information that we collected. We can correlate the number of users that we put in our load driver, correlate this with the CPU usage and business transactions. So it's really helpful to have all this data in a flexible and analytical and analyzable format. So that's Prometheus. And, well, let's finally build our testing environment, one bit by another bit. So we do have our Java application up here. And if you want to do load tests, well, you probably need to have a load driver. So that's going to be Gatling in our example. And Gatling will simulate users and be calling our Java application. So that's the start. So that's quite reasonable for a first load test. But now we have Prometheus in the picture, and we need to fill the database of Prometheus with all the metrics that we want to know about. So one thing we are probably interested is like the host usage, how much of I/O capacity are we using on a host, how much CPU are we using. So that's where we install the node export on the different machines where our application is running. And Prometheus pulls information about all this to its database. If we're running containers, we install something like cAdvisor. cAdvisor collects information about all the Docker containers that are running. So it now knows about the Docker images, their names, and it can also break down the CPU usage to a single container and the memory usage to a single container. All this information is again pulled by Prometheus to its database. So this is our infrastructure view. But then we want to go one step further, at least two steps further. We want to have our load metrics. So the load driver also generates information. So how many users are currently active as simulated by the load driver. We also have the response times observed by the load driver. All this information needs to be pulled by Prometheus and actually pulled in this setup here from a graphite exporter because Gatling and JMeter can export this information not directly to Prometheus, as at least in the version that they're shipped from the Gatling and JMeter homepage, but they first ship it to the graphite exporter, and from there, Prometheus can pull this information. And finally, we also instrument our application. And from our application, we can pull, maybe if we're doing a Java application, we can pull some JVM metrics. If we're doing a Go application, we can have all the memory pools of Go and other things. But we also pull information about the business transactions that we are interested in. For example, how often has been there a login call or a bank transfer, whatever your business is. And now finally, the database is filled with all the information that we need to analyze what is happening during the load test. And then we query this information. And to query this, we use Grafana. Grafana is the one primary tool to do dashboards with Prometheus. And then we build our dashboards. There are different projects I've been in. Sometimes the team that built the application set up the test environments all by themselves, including all the blocks that you see here. But there's also a chance that you say, well, maybe you have people who are in an infrastructure team to provide services to product teams who build the applications. Then at some point you set up all the, well, red, purple blocks as an infrastructure team, like a Prometheus instance plus all the exporters and Grafana you see around. And then the products teams come. They use the test environment, they add more applications, they add more dashboards, but on their own. They don't need to really talk to each other once the initial setup has been done. So they can add more applications to be monitored, more load tests, more dashboards in there. And that's a good thing. So that's, I think, then true DevOps spirit, right? So you have APIs, something ready installed infrastructure, and you just, as a product team, build upon that infrastructure and get things done. Right. And then you get dashboards like this, maybe. So you get CPU usage, you get IOPS, whatever there is. But that's all something you need to, well, as a product team, need to put into Grafana to build the dashboards. But, well, if you're then getting started with Prometheus, you need to configure it. Let's build it from what? From the very, very low foundations. It's all about configuration files, as I said. In this case, Prometheus is now pulling information, or scraping, as it's being called in Prometheus world, from a node exporter. And you can do static configurations like this. So I put in here an IP address and the port. But you can also use DNS discovery, or if you have a Kubernetes around, it can pull information from Kubernetes to discover all the targets it needs to pull. But for a start, static configuration is just fine. And then it will pull information from this host exporter. And let's start with a live demo. So actually, this information looks like this. The node exporter is actually a Go binary, so it will export first lots about the Go information that you see here, but it will export all the information about the CPU, the disks that are around. So all those metrics are pulled in one big chunk into the database of Prometheus. And you see here that there's always a help text telling you what is this actually about, the type, and then some metrics. Let's, as an example, start with this node CPU seconds. So that's the counter, and the counter makes it very easy to reason about it, because this counter is being set to 0 when this export is being started, and it's counting up. It's just the number of used CPU seconds, and then Prometheus can pull this information to its database. If it, well, skips a beat, and maybe for some reason was unable to pull this information, there'll still be the counter counting up, and you can reason about what happened in between there. So if you want to have a very short polling interval, you configure it on the Prometheus side. You have done quite a good resolution. In production, you maybe scale it down to a lower resolution. And this will tell me about the CPU, about each core, and each mode the CPU was in gas, in idle, in no wait, whatever mode. That's quite detailed. And this counter, it's then stored in the Prometheus database with all the labels that we've seen on the previous slide. It's telling me about the CPU core, about the mode, and also, well, this original name of this metric is also a label in the end. But Prometheus will add more information to that. It will add all the infrastructure information that there is in Prometheus about that node. That may be the job, the IP address, where this came from. But if you're running in a service discovery environment like Prometheus, you get all the information that you have for the pod, all the labels, annotations, whatever. You can pull all this information to that one metric and use it then later to reason about what actually happened either in production or in your load test. So, well, some calculations. Didn't warn you about math here. So there's going to be a bit of math here. So you have this counter of seconds spent in one mode, and this is, well, not so fancy. So you can do calculations on these counters. And you can apply, for example, if the question is, what percentage of CPU is used per core at a very moment in time? You can apply first, let's start in the middle here. We start here with node CPU. That's the metric we are interested in, and the specific mode. So when is this CPU core actually idle? Then we can say, okay, I want to have not only the seconds that it always goes up, but I want to have a rate, like the rate, the seconds are being burned by the CPU. And I want to have that on an average of 5 minutes. And then I have the inverse. So the inverse of being idle is the used. And then I have now the percentage of my used CPU. To get something simple as that, it might seem a bit, overcomplicated. But it gives you a lot of flexibility, because I can aggregate this not only on a single core, but on a complete node, but also on a cluster. And then other functions come in. For example, I go there and say, okay, the average of CPU core usage on a single host, on an instance, looks like this. I put average by in front of it. I can also go there to aggregate this by a cluster. If I have 2 versions of release A, and I can do an A/B test on CPU usage. So I compare these 2 versions of my software being deployed. And so the good thing is that this database, it's not a silo within Prometheus. It's a source where you can do analytics on. And they are fast. You can build dashboards on that. Right. I'm now switching to the console of Prometheus. You can get then, using all the instance values here, you can get a first graph. Let's see, I probably need to reload this so it looks a bit better. So now you see this node CPU is just an increasing number of CPU seconds used. And if I now, the desk is a bit too, and now get the CPU rate that I put in here, and then have a first dashboard. So this is the console of Prometheus. That's not yet Grafana. And this can be used for instant queries to do analyzing and ad hoc queries on a Prometheus database. But then the next thing you're probably interested is then containers. You wrap your application in containers, multiple containers running on one node, and you want to break down the CPU usage to a single container. And now you can do the same, math in the end, calculations, and reasoning about the metrics that we had with Node Exporter as well. It's also, you find out about how much memory is one container using. If you're on a Linux machine, you can also break this down to single processes. And I can now reason about the rate of CPU usage by container, right, and sum it up by instances. If I have multiple nodes, all that is possible. But I do something like this then using Grafana. Grafana is then a tool where I can build dashboards on, and these dashboards can be persisted. They can be saved in the Grafana database. They can be exported and shared with Git. And the same expressions that we've seen earlier, I can use within Grafana, and I have a little bit of completion, auto-completion. I can have auto-completion about the metric names, and I can give it some descriptions about the labels here. So all of that, what you usually want to see for a good dashboard, will be available in Grafana. And there's a live dashboard, and whenever Grafana refreshes that view here, it's being queried from Prometheus database. And we also had a talk, I think, yesterday here, and you can run millions of time series in one single Prometheus instance to get your dashboards filled with information. But then, who's actually a Java programmer in this room? Just for a chance, Go programmers? All right. So now you need to find out about your metrics about your Java application. So as a Java developer, you're mostly interested in, basic information would be how much memory is my application using. And if you look at it from the outside, you have one pile of memory, but you want to break it down to different memory pools. Also, if you look from the outside, you see CPU usage by a JVM process, but you have no idea if it's actually using that CPU for garbage collection, or is it doing some real processing, right? So you have to look inside your Java application to find out about this. And the same is also true for Go applications. So in order to, well, you get all this information. So it's called JVM underscore memory underscore bytes underscore used. And the same for the garbage collection seconds being used. You can do the same reasoning that we saw earlier about memory usage of Java virtual machines and CPU usage in Java virtual machines. And if you go to my dashboard here, so I'm not running a load test at the very moment, but I'm seeing now and then a spike here, a little spike, when the Java memory usage, yeah, there's now a garbage collection here, and the same moment this one memory pool goes down in the usage. I see all the meta space, the code space, Eden space, survivor space, all the things that I want to know about my Java virtual machine. And that's good. And all this information you get basically for free. Well, for free, but you need to add one more library to a Java program, being the simple client. There's different versions around. In this example, I'm using Spring Boot. But there's also a general purpose JVM client that you can use for any other framework. There are also clients for standard server containers around. So you add one more dependency to your application. You put that to a REST endpoint into your application, either on the standard port or maybe even better on a separate monitoring port. And you initialize Prometheus with an annotation if you're in a Spring Boot environment. Right, and there you go. You get lots of information. I think I have an example here. So when you're running in you have then some JVM metrics, some historics that we see in a second, some HTTP server accounts that you have in here as well. So you get a very good overview. If you're in a Spring Boot world, you can also decide to use Micrometer. Micrometer is a very new tool on the block. It's been basically released at the same time as Spring Boot 2. And it's basically an abstraction on top of, an abstraction on top of several systems that are capable of collecting metrics, including Prometheus. But it allows you to very easily export all the metrics that are in the Spring universe to Prometheus and to make them visible over there. And all the standard metrics are fine, but then you, at some point, as said, you also want to capture some more, business activities in your application. And, in a Java world, there are annotations. They can be used for almost everything. But they can also be used to collect timings. In this example, I'm using Micrometer. You can put an add-timed annotation on any method of a Java Spring Bean. And then you have, for each add-timed annotation, 2 more metrics in there. How often has it been called? And how much wall clock time has this method been consuming? Right. So you enable this aspect that is currently being, maybe that will not be necessary in future releases. And then you put an annotation like this to your Spring Bean methods. So now it's starting counting. So you can now find out how often this method has been called and how much time it has consumed. So this is internal. You know now what your application is doing internally. But then you have interfaces to external systems. And what comes in there, there's historics. I don't know who've heard about historics. Historics is a circuit breaker library out of Netflix universe. You can you add just another annotation to all your external calls from your Java application to an external application. It then adds circuit breaker logic. Circuit breaker logic being, if the other service fails too often, it will switch it off for a certain amount of time. Is there a failure? It will call a backup, a fallback that you implemented. But it will also collect lots of timing information to actually do that magic. And there's a bridge that takes all the metrics that are being collected by historics and transfers that to Prometheus. So it's also in the database. So you can really reason about what is happening between your services that are being called by the and triggered by the load test. Yeah. Again, at some point you register this, like this bridge for this matrix, and then you run this, add this annotation to this method, and then you have another metric here. So we now see a little bit of demo already, but let's start the load test. So now I start the load test here. So this is Gatling. Gatling has only a command line when it comes to running tests. And now we can have a look at our Gatling again. So we now see here the number of users that are already completed. So this is now increasing every second as Gatling is running and running all its tests. I can see that the CPU usage is now increasing, especially for Spring container, having a Spring application in here. All the other services that are running on my virtual machine here, having now far less than CPU usage than my Spring application. Yeah, and I now see the garbage collection is below 1%, 0.5%. So my application is doing something meaningful and not doing just garbage collection. I see all the memory pools. I see also the results. So then the average duration of the add time call is about 100 milliseconds in my example here. With Hystrix, I see all the information about outgoing calls. I see the operations per second that are now here around like 70 operations per second are successful. For 15, I get some exceptions and fallbacks being called. So I can drill down to all this information in here. And Hystrix also provides me duration quantiles. So it tells me like 99% of all external calls have been completed within 247 milliseconds. And now I can, well, reason about if it's my application that is slow or if I can blame somebody else who slows my application down. Right. And well, this way, the developers in all those projects, they got a user story for their sprints, and the business tells them this is what the load that we expect. And the developers, they actually implemented that load test. And they built their own dashboards that showed all the necessary information they needed for their load test to analyze what's actually happening. And they also did the instrumentation about all the metrics. And finally, they were proud to say, after some iterations, yes, we managed to stay alive with all that load that you said that's going to be in the future. Right. So that was the backup for the demo. The demo worked. So what to expect? What are the lessons learned from a real project? Well, teams usually start with CPU usage per container and RAM usage per container. But that's just an outside view. That gives you an idea if you have a microservice architecture, which microservice might be using a bit of too much CPU or too much RAM, but it doesn't give you very much insight. You get more insights if you actually drill down and go to the Java metrics. If you use counters and count actually how often a call was successful, how often it failed, and this gives you the valuable information that you need. There's gauges, well, a difficult word for a German, for the queues and pools. If my database pool is, well, not big enough or just idle, if the queues are piling up, something that I have to look at. There are lots of libraries that already collect metrics, for example, Drop Wizard metrics. Maybe somebody heard of that and used that before. So there's a bridge that allows you to export all the Drop Wizard metrics that you're already collecting to Prometheus using the simple client. So just another bridge, like we've seen for Hystrix. But in our current projects, we are now using Micrometer. And also this Hystrix gives you great visibility of how your services are interacting with each other, and also if there are failures in communication. So we did a lot of correlation, of load testing, of metrics. And it was really self-service functionality. The developer didn't really need to touch any of these infrastructure bits, but they really concentrated on adding metrics to the application and creating a dashboard. And this will give you some metrics to start with in production. But if you probably want to look in production and maybe taking more of an ops view and want to have like good naming conventions for all your metrics so that they maybe are similar for different projects, you should at least advertise for a common naming metric here. So this makes it then easier to build dashboards across applications. Yeah. On the other hand, the barrier should not be too high, otherwise people will not add metrics to the applications because if you add too much red tape to it, that's just well, hindering innovation here. So the other thing is, whenever you can go for Micrometer, go for it, because with drop wizard metrics, you can't add the proper type and help descriptions in there because the drop wizard API doesn't give you possibility to add that. So please, if possible, go for Micrometer. At some point, you need to find out about counters and average, and histograms and how all these things work together. The good thing about counters is that you can aggregate them for a cluster. So how many requests did I serve in my cluster? But if you calculate averages on each node in your cluster, you can't, well, create a reason or a meaningful average of averages in your cluster. So it will not deliver good information for you. The nice thing about Prometheus is that you can create histograms and buckets distributed, and it allows you to aggregate that for a cluster. So we can create a meaningful 99% percentile response time within your cluster over different nodes. Prometheus has a capability to do that for you. And if you are thinking about what metrics to put in here, so there's, if you want to find out what should I method, then there's something like a use method, a red method, or the Google's 4 golden signals. So there are 3 different ways to actually find the right metrics. Maybe it's a good thing that your company adheres to one of these 3, but that's something you probably want to advocate, probably if you're in a system reliability engineer role, that you decide for one of these 3. Good. The thing is, from my experience, Prometheus is friendly tech in your environment. It's easy to set up. At least every environment should have its own Prometheus. But even maybe it's a good idea to have one Prometheus instance for each team, because then this team can really reason about how much memory I want to give it, how often do I want to scrape these services. Maybe I want to scrape as team A even the metrics from team B because I want to see them in my load tests or in my production environment. And then you're very flexible to set up things. And the footprint of Prometheus is quite low, so you can do that without lots of infrastructure costs. It's also coder and continuous delivery friendly. All the configurations that we've seen here, they can be checked into Git. Even the dashboards, they can be exported and put to Git. There's another, so they have a big JSON block in your Git. That's maybe not the best thing, but it works. There's also a library from Weaveworks where you can script your dashboards in your IDE, if that's what you want to do. And while they're guarded by version controlling, you can stage them from one environment to the other. And you can test everything locally first before you commit it, and then push it to the other environments. And that's really neat. All the tools, well, most of the exporters that we've seen, and that's including Prometheus, it's all Go binaries. It's a single binary. You put them on the server, you start them, maybe point them to some directories where it should store some state, and that's it. And they're available for the major operating systems. For Linux, for macOS, even for Windows. I've seen people running Prometheus on Windows, on production systems, because they're Windows shop. So it works. And the client libraries, they're available for several languages, for Java and Go, that's what I mentioned. But there are other libraries around. You can write your own exporters. There are exporters ready to go for the different databases you could think of, MySQL, Postgres, whatever. So that's very, very helpful. Right. So that's the end of the talk. Thank you very much.